Stop. I will stop record and
Stop,
start another
please.
new one. Okay. Make a stop record.
You will
Stop
stop
it.
dog.
Stop it. Yes, stop it and make a new one to start with.
I cannot stop dog. It's saying
Okay. Yes. Start share screen and start recording.
تمام بسم الله. Okay, Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Good evening. In data analytics, so this is the part 2 now. So where I will talk about the sampling and discuss the two types of data. Let's now discuss sampling and why we perform sampling. We usually have the data population. For example, I have selected a study I want to conduct on the population, and I chose that my population consists of, for instance, people with type 2 diabetes. Okay, I found that the population size is very large. So if I were to carry out the study on the entire population, it would cost me a lot of resources and I wouldn't be able to apply it to the whole population. So therefore, this is where the concept or term of sampling arises. I want to create a sample, and this sample should represent the entire population so that the study I conduct on the selected sample can be generalized to the entire population. A statistical population or population is the group of cases that specific criteria, such as the type 2 diabetes. When we say population, this represents big letter N. So the sample, on the other hand, is a subset drawn, which represents the small n, from the larger population to represent it accurately. The importance of proper sampling lies in what? In allowing the generalization of results to the larger population. The sampling process, this involves the definition or defining the population, is to identify the target group for the study, means selecting a representative sample and analyzing the data to generalize the study to the entire population. Here, in the sampling process itself, when you come to perform sampling or want to take a sample, the first thing is to what? One, to define what is population and define the target group or stock. Then choose the sample, which is the representative subset without any bias, ensuring there is no bias at all. After that, you have to analyze the data and work on the sample you have for the study you are conducting. Following this, you generalize this study or research to the entire population. Okay, in here, you define the data and work on the sample you have, which will be the study you are conducting. After that, you generalize the study or research to the entire population. Now, we have two types of sampling. We have the probability sampling and the non-probability sampling. When we say probability sampling, this means you take random samples from the population and conduct your study without any bias. So there is no favoritism toward any group among those you are sampling. So as a result, the study you conduct can be a generalized to the full population. So when we say the probability sampling, every element of the population has an equal random chance of being selected. So for example, if the population, for example, if the population consists of females over 55 years old and you randomly select individuals from this group. So this is probability sampling because there is no bias. It's purely random. Okay, now in non-probability sampling, this sampling lessens the probability that the findings can be generalized to others. So meaning there is an intentional bias, or there is intentional bias is present. So in case of intentional bias, you won't be able to generalize cannot be generalized to the entire population. So for example, if your population consists of females over 55 years old and you select individuals from this group randomly, so that is probability sampling. But if you decide to select only 55 years old and who also have high blood pressure, can your study be generalized to the entire population? Of course, no, because you used a specific selection of criteria that creates bias. Okay, that creates bias. So this bias makes the study applicable only to females over 55 years old with high blood pressure, not to the entire population. So this is what we call the non-probability sampling. So let's now look at the types within each sampling method. In sampling, we have a simple random sampling. When we say simple random sampling, this means that all names in the same box and choose randomly. So as they say, like putting all the names in a box and choosing randomly. This ensures it's a simple random sample where everyone has an equal chance of being chosen. Okay, so for example, if I have a population with many people, okay, just like this. So I select a random sample from them. So anyone can be selected. Okay, so what about now the stratified sampling? What is stratified sampling? So it means dividing the people into homogeneous categories. When we say homogeneous, these are similar or has a standard of population and selecting appropriate number of persons that represents the population. Okay, you have question, Radha? Okay, so for example, I separate males into one group, okay, from females into another and kids into another. So after that, I choose randomly from each group. For instance, I select 5 males, okay, 5 males and 5 females and 5 kids from each group. So this is still a random sampling, but is specifically a stratified random sampling, where you divide the population into groups and then take an equal number randomly from each group. So what's next? It says, I will also divide the population as it is, but from the population I have divided. So I will group it into cluster. So this is called cluster random sampling. So meaning arrange the population in groups or clusters, but take 2 or 3 or 4 whole clusters, not choose from each cluster. For example, I divide my population. Okay, I will divide my population based on colors. So we have red, we have yellow, we have blue, green, and violet. Then I divide the red group into 2 clusters. The males into 2 clusters. Okay, into 2 clusters, the kids into 2 clusters, and so on. So after that, I'll take 1 cluster from each type. For example, 1 cluster from yellow. So 1 cluster from red and 1 cluster from blue. Okay, so these are all the selected. So after that, I'll take 1 cluster from each type. Okay, so 1 cluster, for example, 1 cluster from yellow, 1 cluster from red, and 1 cluster from blue. So this is called the cluster sampling. So what's the difference between the cluster sampling and the stratified sampling? In stratified cluster sampling, I take an equal number from each group I divided. So for instance, if I divided male into 4 clusters, okay, to 4 clusters, kids into 4 clusters and females into 4 clusters, I will take an equal number from each cluster. So for example, I'll take one from here, I take one from here, so one from here and so on. So from each cluster. So this is what you call the stratified cluster sampling, because I'm taking an equal number from all the clusters. So equal from here, I'll take from here, and here. So I'm taking all an equal number from all these clusters divided. But in cluster sampling, I divide each type into 2 or 3 clusters. So can be 2 or can be 3. So, and then I take one entire cluster at once. So I will not take individuals from each cluster. Instead, I take one cluster as a whole. Okay, this one cluster, and 1 cluster, and so on. Okay, so I take one cluster as a whole. So for example, 1 cluster from yellow, 1 cluster from red, and 1 cluster from blue. So this is what you call the random, okay, cluster sampling. All right, so do you have any question? Radha?
No.
Okay, so let's move on. We have the systematic random sampling. This is a common method that often appears in question. So in systematic random sampling, this you have to randomly selecting the first case, and then the computer will select every nth case based on the fixed standard. So you select first the first case, and then the system will automatically select the rest of the elements based on a pattern. So for example, if you select the first sample as number 2, okay, here is our sample, number 2. The system will skip the 2 cases, so 1, 2, and select the third, okay? We will select the third, which is the 1, 2, 3, okay. We will select the third, which is the 5th. And then 2 cases will be skipped. And select this third again, and skip another 2, and you choose the third number. Okay, so this is the sample in every third. Is this clear, Radha?
No.
Okay, I will repeat.
Okay.
I will repeat. When we say systematic random sampling, is selecting the first case, and then the computer will select every nth case based on the fixed standard by picking a method of identifying subjects randomly before starting. So this one requires a strict adherence because, for example, okay, we will have this sample here. Suppose a supermarket wants to study buying habits of their customers, then using systematic sampling, they can choose every 10th or 15th customer entering the supermarket and conduct a study on this sample. So every time when the customer comes in the supermarket, so one has to count in every 10th customer, that customer is included in the study. You understand?
Okay.
So for example, customer on the 15th customer will come inside the market, then that 15th customer is included in your random sampling. So that depends on you. If you want to use 5th customer or the 7th customer, so every time you count, when you stop after the 7th, then that's your customer or sample to be included in your study. You understand?
Yeah.
Is it clear now?
Yeah.
Okay. Now for non-probability sampling. Okay. For non-probability sampling, there is a bias, as I've mentioned, and you cannot generalize the results to the entire population. The first type of non-probability sampling is what we call the convenience sampling. What is convenience sampling? This involves using data most readily available. So we have example, all patients in emergency department in a given day. So this one, something involves using that that is the data that is more readily available. For example, if I told you to bring me patients who visited the ER on Saturday and then base the study on them, can this study or these patients represent all patients who come throughout the week? And can this patient who visit the ER also represent all types of patients across other departments? Definitely no, because this is called convenience sampling. When you get a question like this in an exam, if I chose patients from a specific department on a certain day, that is convenience sampling. For instance,
Yes.
if I say patient in the ER department on a given day, that is a convenience sampling. Okay, the second type is the quota sampling. When we say quota sampling, this involves taking percentage. So for example, if I have 1,500 elderly living in a residential setting, so consisting of 1,000 females and 500 males. Okay, so I will take a percentage from each group. Okay, so the percentage remains fixed, but the numbers are not equal. So for example, if I take 2%, okay, 2% of the female from the 1,000, so that will be 20. And if I take 2% of the from the female from the 500, then that will give me 10. So here, this one 20 and this one 10. So here the percentage is fixed, which is the 2%. Okay, so but the number is differ. So this is the quota sampling, because when you take a fixed percentage, it is a quota sampling. Okay, so the key points here is the population with a total of 1,500 elderly individuals. This includes the 1,000 female and 500 males. So for the quota sample, sampling is done based on proportions, okay, based on the proportion from the population, because from the 1,000 females and 100 females are selected. So just for example, so from the 500 males, 50 males are selected, ensuring that the sample reflects from the population's composition from these 1,500 in terms of the gender distribution. Okay, so any question regarding this? Okay. Let's move on to another non-probability is the purposive or judgment sampling. Okay, so defining the criteria for selecting a sample from a certain populations, it is the core of the sampling process, whether it's random or uses the snowball method. When we say purposive or judgment, is by selecting persons that they demonstrate desired characteristics. So example, all patients over 60 years old with total hip replacement. So it's by selecting persons that they demonstrate desired characteristics. So in here, you determine the criteria that you want from the population you are selecting. So we have an example here. If your entire population consists of patients over 60 years old, and you specify that you want all patients over 60 years old with hyperthyroidism, for example. So you've set a specific selection criterion, which is with hyperthyroidism and who are 30 years old. Okay. So this criterion doesn't apply to the entire population because your population is only individuals over 60 years old. However, when you say you want people over 60 who have had hyperthyroidism surgery, you have further narrowed the population or the sample. So this is sampling based on a specific criteria that is called the judgment. When we say the snowball, this works like a snowball that grows as it rolls. So for instance, when sampling for diseases like HIV or COVID, okay, COVID-19, any communicable disease. So how do you conduct it? You start with one person okay, and identify whom they have been in contact with. Maybe their son, their daughter, and you look at whom the son or daughter has been in contact with, such as their children. Then you check who their children have been in contact with, like friends and so on. So you start with one person and you expand as you go, growing your sample size gradually, just like the snowball. So in summary, there are two types of sampling. So we have the probability sampling, which composed of the simple random sampling, stratified random sampling, cluster random sampling, and the systematic random sampling. When we say non-probability sampling, we have the convenience sampling, the quota sampling, purposive or judgment sampling, and the snowball sampling. Do you have any question? Okay, so let's proceed. Now about the sample size. Is it better to have a small sample size or a large sample size, Radha? What do you think?
Small sample size.
To ensure that the study is more accurate, should the sample size be small or large? What's your answer? Small? You're wrong. Because larger sample sizes generally provide more accurate representations of the population and increase the confidence in results. Large, of course, because it is stated that a large sample size provides a more accurate presentation of the overall population, thus increases the confidence in the results. So here's a general guideline for sampling. Okay. If the population is, okay, this is our population size. If the population is less than 30, so this is less than 30 cases, then take all of them. Okay, so meaning minimum is 30 cases. 30. Yes. So what about if your cases are 30, between 30 to 100? So how many sample size you will take?
Again, 30.
Yeah, the 30 cases, of course. From 101 to 500 cases, so you will take 50 cases. And if it is more than 500 cases, how much you will take?
700.
The sample size, the 70 cases. So that's
so
how.
if these numbers are fixed for this range?
For this one, this is the
range,
JCI.
30 to
this
100,
is according.
101 to
Okay,
according
this is
to
according
JCI.
to the JCI sampling general guidelines.
Okay.
Okay, so that is how you work with the sample size. Okay. So everything clear to you? Yeah. Okay, alhamdulillah. So let's talk about the statistics. In statistics, the most important thing is knowing how to identify the type of data. We have here the non-parametric, or we call it the categorical data. So this includes attributes, discrete, nominal, ordinal, and they call as qualitative data. Okay. Okay, so another type of data is we have the continuous data or the parametric. Understanding these categories are essential for statistical analysis, as the type of data determines how we analyze it, measure its central tendency, and visualize it. For the non-parametric data or categorical data, is often referred to as the categorical, as it is a qualitative in nature, meaning it describes attribute, as I've mentioned, the qualities, characteristics, or classifications. So it can be verbal, numeric, or descriptive. Non-parametric data is a what? A non-continuous data. Okay, because it doesn't allow for fractional or any decimal values, because it is classified into categories or groups or subcategories, like we have the discrete data. When we say discrete data, okay, this consists of numeric values, but these values must be whole numbers. No decimal or fractures are allowed. So for example, the number of visits, patients visit, you cannot say a patient visited 1.25 or 1.5 times, right? So it's either once or twice or none at all. So this type of data is common in situations where we count events or occurrences. What about nominal? This data that represents the categories without any inherent order. Example, we have gender. So we only have two genders, male and female. What about for the blood type? So we know so far A, type B, type O, and type AB. Okay, clear? What about for the ordinal data? This is data that has an order or ranking, but the intervals between ranks are not consistent. So example, we have the pain scales from 1 to 10, or satisfaction levels from poor, fair, good to excellent. So these are example of the ordinal data. Another example for parametric data is the members, patients, the births, the procedures, occurrences, and the gender, as I mentioned. Okay. So for the usual statistical test of difference between the two groups, the chi-square is under non-parametric. I will discuss this one later. And for the usual display tools, we use the pi, Pareto, and the bar. Okay. So in measuring the central tendency in the non-parametric data, our mode and the median. Okay. The mode and the median. Mode and the median. So which identifies the most frequent occurring category. So which is the nominal. The nominal data here, which is also the mode, the most common measure is the mode, which identifies the most frequently occurring data. While for the ordinal data, we use the median, which is the middle value when the data is ordered. To present, as I mentioned, the non-parametric data, we use the pie charts for showing proportions within categories. So for example, percentage of male versus female patients. When we say Pareto charts, this is to highlight the most significant categories. For example, the leading causes of medical errors. And for the bar charts, this to compare the frequency of different categories. For example, number of procedures by type. Okay, so moving on to the continuous data, which is the parametric data. So let's move on to this, because this type of data is purely numerical and allows for more precise measurement. It is a quantitative data. A continuous data can take any numeric value, including the fractions and decimals. So it is measurable rather than countable. So we have examples of continuous data here, like age, height, weight, temperature, time, charges, like the money, and the length of stay. For the subcategory of the continuous data, we have the interval data. These are numerical values where the difference between 2 points is meaningful, but there's no true 0 point. That is the interval. For the ratio data, these data points have a meaningful 0, and both differences and ratios between values are significant. I will delve more of this later during our more discussion. For example, of the ratio data, we have the blood pressure measurements. For example, systolic to diastolic ratio, also height or the weight. In measuring the central tendency in continuous data parametric, the mean here is the most appropriate measure for the central tendency for a continuous data because it takes into account all values in the data set. And how this usual or how to display this. So by using the tool, using the histogram, okay, to show the frequency distribution of data. For example, the weight of patients. We also have the run chart to track the trends over time. So for example, the daily patient admissions. So that can be presented through run charts. Also, we have the control charts, is to analyze variations in the process over time. For example, monitoring blood pressure reading. So always remember, for the non-parametric, the tools that that is used are these three: the pie, Pareto, and the bar. For the continuous data or parametric are always these three. So we have the histogram, run chart, and control chart. Clear?
Okay.
Okay, do you have any question?
So far, no.
Okay.
Maybe after
So,
reading again.
okay. So in conclusion, understanding whether data is parametric or continuous is crucial because it dictates how you analyze, to visualize, and interpret it. For the non-parametric data, used for categorical variables, where the focus is on counting or classifications. Tools like the chi-square test and bar charts are commonly used. For the continuous data or the parametric data, used for measurable variables, where calculations like the mean and statistical tests like the t-test or ANOVA come into play. So if you understand the type of this data that you are working with, you can confidentially choose the right statistical method and tools to analyze and present your data effectively. For non-continuous data is, I said a while ago, use the bar, the pie, and the Pareto. So example includes the patient visits, causes of problems, or medical errors. For the continuous, use the histogram or the non-control charts. And this includes the length of stay, weight, age, or height. So when we solve the questions, it's crucial to understand the data type and the corresponding tools for display. This understanding is essential for the data analysis. Okay. So do you have any question regarding this?
No.
The difference between non-parametric and parametric? If none,
Okay.
so
Okay.
let's proceed. So
Okay.
how to describe a large set of data? So in here, we have to measure the central tendency that focuses on identifying the middle value or the central point in a data set. It answers the
Mean.
question, what is the average or middle value? So there are three types of the measuring central tendency. We have the arithmetic mean, okay? We have the median and the mode, the nominal. When we say arithmetic mean, that represents big letter M, or it is a continuous data, is the average value calculated by summing all values and dividing by the total count. So example, if you're analyzing the weights of patients, the mean gives you the overall average weight. Okay, what about the median? It is an ordinal data. This is the middle value when the data is arranged in ascending or descending order. So for example, in a pain scale from 1 to 10, okay, the median tells us the midpoint of the responses. For example, what is the middle here? It is the 5. That's the median. For the mode, used for nominal data, the most frequently occurring value or category in the data set. So for example, the most common blood group in a population is O positive. Yes. So these measures provide a simple summary of the data set, making it easier to interpret trends and patterns. Don't worry, Radha. After this, I will discuss it more furtherly. Okay. So next is the measuring of the variability or dispersion. While central tendency tell us the middle, variability means measures how spread out the data is. So it answers the question how far the data points from the central value. So we have, it can be mean or median or mode. So we have the types, we have the range, standard deviation, and interpercentile measures, yes. For the range, this is the difference between the, largest and smallest value. Yes, so this is, okay, R to a largest and minus the smallest value. So if example, the age range from 20 to 80, okay, 20 to 80 years old. So the range
60.
is 60.
60.
Very, very good. Okay. So the answer is 60. What about the standard deviation? A measure of how much individual data point deviate from the mean. So for example, in a data set of patient weights, a small standard deviation means most patients have similar weights, while a large standard deviation indicates a wide variation in weights. So let's move on to the interpercentile measures. This focuses on a specific percentile of the data, such as the 25th, 50th, which is the median, okay, and 75th, which percentile. Examples, the middle, 50% of the data, which is the interquartile range. This helps identify the spread without being affected by the extreme outliers. Okay, so next will be the frequency distribution. This focuses.
Can I have one question?
Oh, hi, Doc.
Assalamu alaikum. Yes, I'm hearing simply. Just I want how the range of 20 to 80, the 60 was the answer for this question.
Sorry, Doc. I'm sorry.
How in this example, the range 20 to 80, why the 60 been as accepted in this range? What is the 60 rationale of 60 in 20 to 80 range?
Okay, so when we look at the meaning of the range here is the difference between the largest. So what is the largest? The 80, right? So what is the smallest, Doc? 20.
Yeah.
So that's what's the answer? It's the
Which is
60.
only the difference?
Yes. So this one, yes, because the formula for the range later on, Doc, we we have the formula here, and then you will understand more. Okay, thank you for that question. Okay, next, so I will proceed about the frequency distribution. Okay, for the frequency distribution, this focuses on how often data values or categories occur. So it helps to understand different patterns like the proportions and comparisons in the data. Like when we see proportion, a ratio of a part to the whole, often expressed as percentage, the proportion. Okay, this is percentage. And the example is the proportion of male patients in a clinic compared to the total number of the patients. So when we say ratio, this is relationship between two independent groups. So example, the ratio of male to female patient in a study. So that is ratio. When we say rate, similar to our proportion, but includes a time period. Okay, so for example, the rate of hospital admissions over a month. So that is a rate. So these measures are essential for comparing the data sets and identifying the significant differences or trends over time. So I want to summarize when describing a large data set. So we use the central tendency measures to summarize the center of the data, means the mean, the median, and the mode, while using the variability measures to understand the spread of dispersion of the data by using the range standard deviation, and use frequency distribution measures to identify the patterns, the proportions, and relationships between data points. Okay, so we have the proportion, ratio, and the rate. So by combining these tools, you can create a complete and easy to understand picture of the data set, making it easier to analyze and interpret. Okay, so moving on. Now let's move on to the, we will discuss on the measuring the central tendency. I previously explained that central tendency is measured by the mean, median, and mode. When we say arithmetic mean, this is the average of the data or mean. To calculate the mean, sum up all the values and divide by their count. So for example, here, if the data is 6 plus 3 and 8 plus 5 plus 3. Okay, so how do we calculate the mean? The sum of values So meaning the sum of the 6 plus 3 plus 8 plus 5 plus 3 is equals to 25. So how many number of values do we have? So 1, 2, 3, 4, 5. So 25 over 5. So that will give us an answer of 5. Means this is a continuous data. Okay, is this clear? Arithmetic mean.
Clear, clear.
Okay, what about the weighted mean? It is similar to an arithmetic mean, where instead of each data point contributing equally to the final average. So some data points contribute to more than others. So in some cases, values are assigned different weights based on their importance. So for instance, if you are analyzing departments like parking, medication, communication, nutrition, and you might assign weights. Like for example, for the parking, so we will give 1. For the medication, so we will give 2. For communication, we will give 3. And nutrition, we will give 1. So how to calculate the weighted mean? So by multiply each value by its weight. So for example, we have a value here of a score 65 times 1. That will give us 65. Okay, 60 times 1 will give us 60. 80 times 2, 160. And 95 times 3, that will give us 285. So multiply each value by weights and sum the weighted score. So these are the weighted scores. So we have to total all of this. So how many now the sum of the weights by adding all of this? So we have 7 here. So how much is the total here? 65 plus 60 plus 160 to 85. What's the answer, Radha? Dokulam? Okay. So this one, you just have to plus, and plus, add total, and over how much? 1 plus 1, 2 plus 2, 4 plus 3, 7.
518.
Okay,
580
so
by
what's the
7.
answer? Yes. What's the answer, Doc? This is 5. Okay.
7.
So that will give us more than 80. Okay. Hold on.
Almost,
We will
almost
solve
79.
together.
Yeah.
So
70.
65 plus 60 plus
570.
160
It is
plus
580.
285. So will give us 570. Okay.
570.
Yes. 570 over the weighted answer here
7.
over 7. That will give us how much? What's the answer? Divide by 7 will give
Yeah.
us
81.4.
81. Yes.
Yeah.
So that is now the weighted mean. 81. Clear? Okay. So the weighted mean calculation helps when values have different level of importance. So if you're asked to calculate it in exam, so the weights will already be provided. So don't worry, these are all provided. So you just multiply, sum, and divide accordingly. Clear? Do not forget.
Yeah.
Okay, let's move on. Median. This is also referred to as the 50th percentile. So that score point at or above which 50% of cases fall, and at or below which 50% of cases fall. So when we say median, this is an ordinal data. So the median represents the value in the middle of a data set that splits it into 2 equal halves. One half on the left and the other on the right. So how to calculate the median? First, okay, so we have to arrange the data in ascending or descending order. So for example, if the numbers are, okay, if the numbers are 3, 3, 5, 6, and 8, ensure they are sorted out. So apply the formula of n plus 1
By 2.
over 2. Okay, this is the formula. So what about odd numbers are presented as the value? So for example, here we have here 3, 3, 5, 6, and 8. So
The middle number is
how many
5.
total values do we have here?
1,
How many total?
5.
Okay,
5,
5. So apply now the formula
5
of
plus
n plus 1 over 2.
6 by 2,
6
3.
by 2, 3.
Mm-hmm. Okay, so what's the answer? The median is
5.
5. Yes. So,
Plus
okay.
1.
So 3, 3, 5, 6, and 8. So the median here is 3 in the
5.
third position. Okay. In the set of rank ordered, okay, another example. What about for an even number? Okay. A while ago, odd number. What about if the value is an even number? 3, 3, 5, 6, 8, 9.
6.
How many total values do we have here?
6.
1, 2, 3, 4, 5,
6.
6. Yes, 6, meaning it's an even number, right?
Mm.
Okay, you apply the formula now. N plus 1 over 2.
Plus 1.
Mhm.
3.5.
Yes, 3.5. Okay, what's the median answer? What's the median? We have
5.
5.5. Very good. Yes. So this is the median. Because in every total values, for example, the total value is even number. So use the formula 6 plus 1 over 2. So you just divide. So it is 3.5th position. So meaning 1, 2, 3, half. So what is half here? It is 5.5.
5.
Is it clear, Dr. Gulam?
Yeah, yeah.
Okay. Radha, any question?
Yes.
Okay. So what about, for example, the data? Okay. I'll give you an example. For identical numbers, for example, the data here is 2, 2, 2, then 3, 3, 4, 4, and 4. Identical numbers. What is the answer here? What is the median?
That is the even number.
3.
Okay. Yes,
And
very good. The answer is 3. Yes. So these are what? Even numbers.
yeah.
So 8 plus 1 divide by 2. Both values at positions, the 3 and 4, 3 and 4 and 5, I'm sorry, 4 and 5. Both values at positions 4 and 5 are
4 and 5. Even number plus.
Okay, so we have the data here again. So total values of 8, right? Then applying the formula, 8 plus 1 over 2. So we have a total of, the answer is 4.5.
9
So the median is between 4 and 5
5.
positions. So both
So
values
3.5.
at positions 4 and 5 is
3.5.
9.
both values at positions 4 and 5 are 3. Your
Yeah.
answer a while ago was correct, Radha. So you got it correctly. The median is 3. Okay. Another is, if the numbers differ, simply calculate the average of the two middle values. For example, if the 3 and 4 if the third and fourth values are 3 and 6, what about 3 and 6? What is your
3
median
and
here? Median.
3 and 6.
Yes, two numbers only. So you have 3 plus
3
6.
plus 6.
Yes.
9.
9 over 2 will give you?
Over 2 is 4.5.
Yes. So that is your median, 4.5. Clear? Okay. What about the mode? The score that occurs most frequently, that is also called as nominal data. So For example, what about I have here values of 1, 1, 2, 2, 3, 3, and 4. Okay. These are my data. So can you answer?
Most frequently occur number 1.
Okay.
Two
What
and
do you
3.
call
2 and
what do you call if three numbers occur equally often? It is called trimodal. Yes, it is called trimodal. What about, for example, here, 2, 2, 3, 3, 3, 4, and 4?
3.
Mm,
3 occurs more time.
okay. Okay, number 3 here. Okay, the number 3 occurs the most, meaning 3 times. So the mode is
3.
unimodal. If
Trimodal.
one number occurs the most, it's called unimodal. If 3 numbers occur equally often, it's called
Okay, now I
trimodal.
understood. Okay.
Okay. What about this one? Oh, what about this one? 2, 2, 3, 3, 4, 4, 5, and 5. What do you call this one? If one number occurs the most, no, I'm sorry.
Is unimodal.
No. If, okay, this one, please answer this one. 2, 2, 3, 3, 4, 4, 5, 5. The
Is
numbers
trimodal.
2, okay, 3, 4, and 5 all occur
Trimodal.
twice. The mode is
Trimodal.
multimodal.
Multimodal.
Oh,
Oh.
yes. Okay. And that is also we call bimodal if two numbers occur equally often. So you want me to repeat again? Okay. For
No,
this
this
data,
okay.
it's okay? Okay, so
Okay.
Dr. Gulam?
Yeah, it's fine.
Okay, so thank you. So again, the median and mode are critical measures to summarize the data distribution. So let's now proceed. We will discuss the difference between the normal distribution and the skewing. Okay, so these are important facts to remember about the mean, median, and the mode. In here, the normal distribution refers to the natural distribution of any data, which takes this kind of shape. Okay, so the middle line represents the mean. So this is the mean now. Okay, half of the data lies on the positive side and the other half lies on the negative side. When the data is normally distributed, it is continuous data. And the mean, median, and mode all align in the same central line. So what is the standard deviation in normal distribution? It is the distance between the first value, okay, and it is called in the standard deviation. So this is the standard deviation. Data within one standard deviation, both positive and negative, this represents the 68% within the one standard deviation of mean. Okay, so when data within two standard deviation, okay, from here to standard deviation, what does it mean? Extending further on both sides. This represents what? 95%. 95% of the total data. So what about data within? Okay, extended until here. The three standard deviations, 1, 2, and 3 standard deviation, 1 and 2 and 3 standard deviations, covers the 99.7% of the total data. So this is the concept of the normal distribution. What about the skewing? If the distribution shifts to the right or left, we call it skewing. Okay, skewing. When we say positive skewing, when the distribution shifts to the right.
Right side.
And yeah, while the negative skewing, when the distribution shifts to the left side.
Left side.
So what is the relationship between these three in the mean, median, and mode in skewed data? For the normal distribution, the mean, median, and mode are all in the same, okay, here, are all in the same line in the middle. So in skewed distribution, the middle line represents the median, okay? While the mode and mean adjust depending on the skew direction. So for the positive skewing, the median is less than the mean. Okay, less than, median is less than the mean. So for example, if the value here is 2, 4, 6, okay, 8, 10, okay, and the median is 2.
2.
The mean might be 4. Okay? So what about for the negative skewing? The median is greater than the mean. The median is greater than the mean because it's going to the left. So we have here like, for example, -2, -4, -6, -8, and so forth. So this distinction, okay, this distinction between the mean and the median in skewed data is essential for the interpretation of the data accurately. So in here, so the value of -2, the median -2 is greater than the mean.
-4. Mm.
Okay. Okay, I'm sorry. Here, here, -2. I'm sorry, okay? -2 here for the median. Oh yeah, it's correct. -2, green. That represents the median, yes. So -2 is greater than the -4. Clear? Okay, again, for the positive skewing, the median is less than the mean. So for example here, if the values are 2, the median is 2, and our mean is 4, and next 4, 6, 8, and 10, and so on and so forth. So meaning here, the median is 2, the mean might be 4. For the negative skewing, the median is greater than the mean. So for example, if the values are -2 for the mean, median, so a -4 now is less than the median. Okay, so -2 here is greater than the mean. Correct? Is it clear?
Mhm.
Dr.
Okay.
Gulam?
Yes.
Radha?
Yes, yes.
Okay. So any question regarding this? Our normal, what is this? Normal distribution. Do you have any question? Okay, if none, then we will proceed.
Yeah, we'll proceed.
Okay, next will be about, okay, so we have discussed the measures of the central tendency, which include the mean, median, and mode. So now let's look at the variability, which means the data dispersion around the center, mean or median. So when we say range, the range tells you the lowest and highest numbers in a set of numbers, but it does not tell you anything about the numbers between two values. So the distance or the variation from the lowest, which is the smallest, to the highest or the largest value in the distribution. So the highest value minus the lowest value, and that is
Range.
the range. So this is the formula of the range. R is equals to highest value minus the lowest
Lowest
value.
value.
So this was your question, Dr. Gulam.
Yes.
Yeah, so we had a while ago, the age is 80 years old. So we are looking for the range 80 and range 20 years old, the least or the lowest value. That gives us 60 as the range answer. Okay. So we have another set of example here. We have 3, 5, 6, and 8. So the range is how you will answer this? What is our highest value? We have the 8. And
8 minus 3.
deducted by the lowest value, which is 3, that gives us 5 as the range. Okay, so this is the clear measure of variability. What about the standard deviation? The variance, okay, or the standard deviation is the arithmetic mean of the squared differences between each value and the mean value. So standard deviation tells the average number of score units by which individuals, objects, or events deviate from the mean. So standard deviation is the square root of variance. Standard deviation is a continuous data. Okay, so this measures how much the data deviates from the mean. So as you can remember in here, okay, so how much the data deviates from the mean, because our center here is here, the mean is in the middle. So this is our standard deviations. So this one measures how much the data deviates from the mean. Okay. So while the detailed manual calculations of the standard deviation, this involves multiple steps. So it is typically calculated automatically using a software actually. So there are key points to remember here. The standard deviation is a measure of what? Dispersion. Okay, dispersion. It provides insight into how spread out the data values are around the mean. So that's it. So we will continue with the next measures of variability. So is everything clear to you?
Yeah.
If none, then let's proceed to the measuring the frequency distribution. So which refers to the repetition or recurrence of data. So we have proportion. This is a type of ratio in which the events included in the numerator must also be included in the denominator. So what does this mean? It means that the numerator as a part of a subset of the denominator, which is the whole. Okay. So example, let's calculate the proportion of surgical wound infections. Suppose you conducted 60 surgical procedures. So out of this, 3 procedures resulted in surgical wound infections. Okay, this is the part which is the numerator with the 3 surgical wound infections, and the denominator, which you call it as the whole, has a 60 surgical procedure performed. So what you will do to find the proportion is to divide the numerator, which is the 3 surgical wound infections, by the denominator of total 60 surgical procedure. So what is the proportion? What is the answer? We have here the 0, okay, 0.05. The result can be expressed as decimal. Okay, so that's why we have 0.05. So how we will convert it into percentage? Yes, by, okay, multiply it by 100. So that will give us 5%. Yes. So the numerator must be subset of the denominator. It can be expressed as either decimal or a percentage. So that is what we meant by proportion. Clear? Next is ratio. A ratio represents the relationship between two populations. But unlike a proportion, the numerator is not included in the denominator. So example, systolic to diastolic blood pressure. The numerator is, what do you think? What is our numerator?
Systolic.
Yes, it's the systolic. And the denominator is diastolic, which are independent. Okay, independent variables. Okay, so the numerator, as I said, is not included in the denominator. And the relationship between two populations, but not part to a whole. So for example, another example, males to females in a group. So what is your numerator?
Male.
Yes, and your denominator is the female. And they are a separate groups. In a ratio, the numerator and denominators are independent and do not overlap. What about rate? A rate is similar to proportion, but it includes an additional component. When we say rate, it's the frequency of events in defined population in a specified time period. So in here, numerator is included in the denominator. Okay. So for example, let's calculate the rate of the surgical wound of infection a while ago. So suppose there were 60 total surgical cases, 3 of which resulted in infections. But this was within a specific year. So for example, 2024. Okay. For example, 2024. So when a time period is specified, it is no longer called a proportion, but a rate. Okay, the formula for rate is, okay, how? Rate is equals to numerator divided by denominator over time period. Okay, another example. To calculate the birth rate, so count the number of births, okay, 1,000 women aged 15 to 44 within a specific calendar year. So by including the time period, you are calculating a rate, not just a proportion. So again, proportion means the numerator is part of the denominator, but without a time component. When we say rate, the numerator is part of the denominator and includes a specific time period. What about the ratio? The numerator and denominator are independent. Is this clear?
Yeah.
Okay. So let's move on to mortality versus morbidity rate. When we say mortality rate, this measures the proportion of deaths within a specific population, locality, region, or health system during a specified time period or time range. As mentioned before, any rate must include a specific time period. So how to calculate for the mortality? You count the number of deaths from chronic disease. Okay, so divide it to the population total population. Okay, so specify the time period. So that is how you do the mortality rate. What about the morbidity? This measures, okay, this is the rate of disease or proportion of deceased person in a given locality, nation, health system at a specified time. To calculate for the morbidity rate, for example, auto accidents, divide the number of deaths. Okay, divide number of deaths tamam, from auto accident. And then by the total number of auto accident during the time period. This is the morbidity rate. Okay. So this is the formula. That's from auto accident divided by the total auto accidents in the specified period. In here, the numerator is part of the denominator because the deaths are part of the total accident. Okay, so is this clear?
Yeah.
Morbidity and mortality rate. Okay, moving on to incidence rate and the prevalence rate. Incidence refers to the rate of occurrence of new cases of a condition within a specific time period. So for example, if we want to calculate the incidence of COVID in 2021, okay, 2021 is the specific time period. So you have to identify the number of new cases of COVID that occurred in 2021. So by dividing it by the population at risk during that period, which is the total population in the area being studied. So this is the incident. Okay, specify the time period. So in this case, I said 20 in the year 2021. For the prevalence rate, on the other hand, this often applies to chronic conditions. This includes both old and new cases of a condition. So for example, if we want to calculate the prevalence of COVID-19 in 2024, so this includes all cases, both new and old, that has occurred up to 2024. By dividing this total by the population at risk during that period. So in here, there is a tips or strategy. So you will not forget, or you will just recall. So in prevalence rate, so meaning AL here, so this represents the all cases over the population at risk. When you want to get the incidence rate, so we have the INN, which stands for new cases over population at risk. Okay, this just only to help you recall. So the differences between these two incidents measures the new cases within a specific time period, while the prevalence measures all cases. So either new plus old within a specific time period. Another example of the incidence of a condition like acute infection. This focuses on how many cases developed in a specific year. So when we say prevalence of a condition like chronic conditions, okay, so this includes all cases. That includes the new and ongoing up to that year. So that's the difference of these two. For the confidence level and p-value. Confidence level, this is the commonly used in scientific research, particularly when reading or conducting studies. What is the confidence level? This is the probability that the sample is truly representative of the population, because this indicates how likely it is that the results are not due to chance, but can be replicated. Okay, so it helps us to determine whether the results of a study are reliable or simply occurred by coincidence. So how is confidence level expressed? It is measured using the p-value. A small p-value indicates that the results are more likely to be true and not due to chance. The smaller the value or decreases, okay, the higher the probability that the results are based on reality rather than random occurrences. So what is the significance of the p-value? P-value is less than 0.05 or 5% or less is generally considered significant. Okay, considered significant. This means there is less than 5% probability that the results are due to chance, which increases confidence in the results. So what about if the p-value is more than 0.05? It suggests high probability, okay? If it is more than 0.5, higher probability that the results may have occurred by chance, reducing confidence in their reliability. Okay, to explain more, the confidence level, this represents how much we can trust that the sample accurately reflects the population. And when we say p-value, this measures the likelihood that the results are due to chance. Okay, as I repeat, when the p-value is less than 0.05, high significance results are likely valid, okay, valid. But when p-value is more than 0.05, meaning the results are more likely due to chance. Okay, so the smaller the p-value, the greater the confidence in the results being real and significant. Clear? Any question? So understanding more of the p-value and its implication. What does a p-value of less than 0.05 mean? So as I've said, if the p-value is if the p-value is equal to or less than 0.05 means there is 95 percent confidence that the results are due to reality, meaning true results. Don't forget this one. There is only 5% probability that the results are due to chance. Very good. What if the p-value is greater than 0.05? So if the p-value is greater than 0.05, for example, we have 7% or 0.07. So what does this mean? There is a probability of 93% that the results are due to reality or true results. What about the 7% here? That the results are due to chance. Yes. So the higher the p-value, the greater the likelihood that the results could be due to chance. So what is the relationship between the p-value and significance? As the p-value decreases, significance increases, meaning the results are more likely reflect to reality. And p-value increases, so meaning the probability that the results are due to chance also increases, reducing the confidence in the results. So for the terminologies, the p-value is also referred as significance level and confidence level. So don't be confused. P-value is also called significance or confidence level. Any questions so far?
No.
Okay. So what about interpreting p-value in drug studies? Okay. So in here, for the pharmaceutical studies, what is the p-value? The p-value is a measure of, as I said, confidence level. If the p-value less than 5% or less, this is a good result. Okay. So this indicates that the results represent reality, and there's an increased likelihood that the results are representative of the population. Conversely, as the p-value increases, so the probability of chance increases. So the and the reliability of the results decreases. Okay. So in the drug studies, the smaller the p-value, the greater the statistical significance. So in a study, if p-value is less than 0.05, there is difference between the treatment group and the placebo group. So the drug is effective because less than 0.005. So there is a measurable effect. So what about if it is more than? So there is no significant difference between the treatment and the placebo groups, which is the drug is not effective. Okay. So that is the significance of the p-value in the drug studies. Okay. So any further question? For the statistical significance test, we have the parametric data here, or the continuous data. We have the t-test. So t-test is used to compare a continuous data. So we have three types of the t-test. So we have the sample t-test, or this is the student. Okay, students t-test. This compares the two different samples. So example is comparing two separate groups from group A, okay, and group B. Okay. So what about the paired sample t-test? This compares the same group before and after the treatment or intervention. So example, comparing a group's condition before and after receiving a drug. So that's the example of a paired sample t-test. What about for the ANOVA test? Used when comparing more than two samples of continuous data. So again, a test for parametric data or continuous data, we have the t-test or the sample t-test, the student t-test, which is comparing of the two samples by simply comparing the group A from group B and vice versa. And we have the ANOVA test to compare more than two samples of a continuous data. While for the paired sample is comparing the same group before and after a treatment or intervention. So this explanation covers the p-value and test for parametric data. Any questions so far? Okay, moving on. If there is none, test for non-parametric data or categorical data is by comparing ratios or the rates. So we have the chi-square x2 test. And we have also comparing two distributions through regression analysis and multiple regression analysis. So when we say chi-square test, it is used for comparing non-continuous data. It is particularly useful when comparing what? Ratio and rates. Okay. The chi-square, okay, between, it helps compare the rates and the ratio between the two samples. So that is a chi-square. What about the regression analysis? Regression is a statistical technique that allows one to compare the entire distribution of observations of one measurement or variable with the entire distribution of another measure in order to determine how the two variables are interrelated or correlated. So it is used to determine whether there is a relationship between two variables. So there are actually okay, when we say regression analysis, this is a simple analysis used to study the relationship between two variables. So the example for this is studying the relationship between obesity and heart failure. Obesity and versus heart failure. Okay, so you have to study the relationship between these two variables and determine if there is a connection between these two variables. When we say multiple regression analysis, is estimating the effects of two or more independent variable X on a dependent measure Y. So for example, here is the relationship between the age, gender, hypertension, cholesterol on diabetes mellitus. So this one is used when studying the relationship between more than two variables. Example is examining how obesity and smoking together affect the heart failure. So again, examining the obesity and smoking together affect the heart failure. So this involves two or more because this is independent, and one dependent variable. So this is about the multiple regression analysis. So again, what's the difference? When we say simple regression analysis, this focuses on one independent variable and one dependent variable. When we say multiple regression analysis, focuses on two or more independent variables and their relationship with a single dependent variable. Clear? Okay, so what's next? After identifying whether there is a relationship, the next step would be to measure the strength of this relationship, which can be explored using these further statistical methods. So this strength is called the correlation coefficient, which is small r. So this determines the strength of the relation. It is said that if R is 0, there is no relationship at all. So no relationship. Okay. So if it is positive, then it is a direct relationship. If it is negative, then it is an inverse. Okay. Inverse relationship. What does that mean? So for example, if you have two variables, the graph that I will use here in the scatter, okay, scatter diagram, which we will study next time, inshallah. So with the tools of the data analytics, but now if we look at it and I want to draw the relationship between two variables, and I find that the points came out like this in a circular shape, meaning I cannot draw a line. Yes, right? Correct? So if I try to draw a line here, it won't cut through most of the points because it is scattered. You see? Is there a, can I draw a straight line here? No. So this means that when we see this circular shape, it means that the correlation coefficient, which is R, is equals to
No
0.
relation.
No relation. Very good. Okay, so this means there is no relation, no correlation at all, meaning there is no relationship at all here. Okay, but if R is equals to positive, okay, if R is equals to positive, meaning if R becomes positive number, it means there is a what? Relationship. Okay, this relationship is positive, meaning it's a direct relationship. So this means that whenever the first variable increases, the other one also increases. When this one also increases, the other part here is also increases. So the curve will be looking, the curve will look like this. So this means the correlation is positive, meaning there is a strong relationship. And here, the positive correlation can be strong or can be medium or intermediate depending on the distribution of the points. Meaning, when all the points fall on the line, then it is a strong relationship. If some points are around the line and some are, let's say, close to the line and some on the line, then it would be intermediate or medium depending on the degree of the relationship. Okay, so if the points came in the opposite direction like this, okay, so then here R would be
Negative.
yes, very good. R here is negative, meaning it is a negative. It is a negative relationship, meaning an inverse relationship, meaning when the first variable increases, the second one decreases with it. Okay, so here R equals negative, meaning it's a negative relationship. It can be a strong negative relationship or medium or intermediate relationship, also depending on whether the line cuts through all the points or some of them, and depending on the strength of R. Okay, so as we said, relationship analysis determines whether there is a relationship or not. The correlation coefficient, which is R, determines the strength of the relationship. So the strength of the relationship, or if it is 0, then there is no relationship at all. Okay, is it clear? Any questions?
No.
Okay, so that's the end of explaining part 2 in data analytics. I hope that it's all clear and understandable for you. Okay, if there is no question, thank you for listening to
Thank
tonight.
you.
And
Thank you.
we will proceed
Thank you so much.
tomorrow of the data analytics part 3. Okay.
Thank you.
Thank you.
Hi, everyone.
Bye-bye.
So now let's proceed to our final quiz, number 2. It has 21 items and it won't take that long. Do you have any question out of the record? So I can explain. Dr. Gulam, Radha?
Today's lecture or previous lectures?
No. Today's lecture. Do you have any clarifications? Okay. Dr. Gulam? Okay, so now let's proceed to final quiz. Final quiz number 2. Number 1, a performance improvement training program has been conducted. The healthcare quality professionals has determined that improvement has not occurred. The most likely cause for the lack of improvement would be that A, organizational systems are inhibiting changes. B, employees practice what they are trained to do. C, staff members thought the program was too long. D, the facilitator did not prepare agenda materials. What's the answer, Radha? Dr. Gulam? Anyone? Okay. The answer here is letter A. Because these systemic barriers within the organization are often preventing the implementation of changes. When we say inhibiting, this one hinders, prevents. So even if training is already conducted, while the other options, the employees practice when they are trained to do, the staff members through programs too long, and the facilitator did not prepare agenda materials, are less likely causes and employees practicing what they have learned. So this would lead to the improvement or program length for letter B. And for letter C, this might affect the engagement, but not outcomes. Okay, for the letter D, this would impact the session, but it will not give any results. For the correct answer is letter A. Organizational systems are inhibiting changes. Okay, number 2. Number 2, replacing retrospective. Replacing retrospective review with concurrent review is an example of a paradigm shift. B, process improvement. C, an empowerment process. D, productivity enhancement. What's your answer? Radha?
Process improvement.
Okay, what's the answer here? So the answer here is letter A, paradigm shift. Okay, because replacing retrospective review with concurrent review, this represents a what? A fundamental change in approach. So when we say this retrospective review, what does this mean? This is reviewing after the fact or after patients already discharged, with the concurrent review, which is the real-time monitoring of the patient. So this represents a fundamental change in approach, which means this shift moves from reactive to proactive processes. So the answer here is paradigm shift. Why not letter A? This also may lead to process improvements, but the change represents a broader fundamental transformation, not just an incremental improvement. So that's the reason. Why not letter C? Because this change, an empowerment process, this change is not directly about empowering individuals, but about modifying the review methodology. What about letter D? This might also improve as a result, but this is a secondary benefit only, not defining the characteristic of the change. The correct answer is paradigm shift. Number 3, which of the following best describe an organization's vision statement? A, it is used as marketing strategy. B, defines the structure of the institutions. Okay, C, it describes the organization's strategic plan. D, it reflects the organization's aspiration. What's
C.
your answer? Letter?
C.
Letter C, no. Okay, this is
Vision
not the
statement.
correct answer. Okay, give me another answer. Best. Which of the following is best describe an organization's vision statement? The answer here is letter.
Aspirate.
Okay,
Oh.
yes, letter B.
B.
It reflects the organization's
Aspirate.
aspiration. Because a vision statement, okay, it represents the organization's long-term aspirations and dreams, providing inspirations and a sense of purpose. Why not letter A? This is incorrect because a vision statement is not primarily a marketing tool. What about letter D? Letter B. This defines the institution's structure. Letter C. It is broader than a specific strategic plan. So the answer is letter D. Clear? Okay. Number 4. Quality improvement initiative progress is best evaluated by which of the following? A, team leaders. B, senior leadership. C, PDCA process. D, nominal group technique. What's your answer, Radha? Doc Gulam? Is Doc Gulam still here? Okay. So he left. Okay. So what's your answer, Radha?
PDCA process.
Very good. Yes, this is the correct answer because this provides a structured method to evaluate the improved quality initiatives systematically. While the other options like the team leader, the senior leadership, the nominal group technique, okay, these are may oversee, okay, or review the progress, but PDCA is the most effective evaluation framework. So, okay, number 5. Which of the following following element must be present in order to evaluate effectiveness of healthcare quality improvement program? What's the answer here? A, integrated data collection. B, quantified objectives. C, well-defined organization culture. D, well-educated medical staff.
Well-defined organization.
Very good. Yes, that's the correct answer. This is essential to evaluate the effectiveness of the healthcare quality improvement because this provides measurable goals or benchmarks that allow for the assessment of progress and success. Okay, why not letter A? This is also useful but not sufficient to evaluate the effectiveness without the specific or measurable objectives. Why not letter C? This one does not directly determine the evaluation of the program effectiveness. Well, also letter D, this is skilled staff are important for program implementation, but their presence does not guarantee a method for evaluating the effectiveness. Okay, number 6, a team has identified a process for improvement, selected examples of best practice performers, visited those sites, gathered all necessary data, and compiled results. The most effective next step for the team is to A, identify the next process to benchmark. B, implement change back at the team site. C, compare results to historical data. D, make the results public for others to use in benchmarking. What's your answer, Radha? What's the answer here? A team has identified a process for improvement. So selected examples of best practice performers, visited those sites, gathered all necessary data, and compiled results. The most effective next step for the team is to what?
Identify the next process to benchmark.
No, to
Oh.
implement change back at the team's site. Why? Because after gathering and analyzing all data from the best practices, which is from the benchmark, the logical next step is to implement these changes at the team's own site, basing on the findings. Because,
Implement.
okay, because this ensures that the lessons learned from the best practices are applied to improve the identified process. Okay, this one also, because applying the findings is the next logical step after gathering all and analyzing the benchmarking data. So letter A here is wrong or incorrect because benchmarking is another process that should only occur after a successful implementing changes, right? And assessing the outcomes of the current improvement effort. For letter C, this is incorrect. Okay, this comparing the results may be useful for evaluation, but not the immediate next step for compiling benchmarking results. For letter D, this is also incorrect because sharing results may happen later, but the priority should be implementing the identified improvements internally. Okay, so in here, if you encounter the question in your exam, so what would be your answer here? So letter A, we have choice. Letter A, the first issue has not been resolved. It needs to be addressed before moving on to the next process. B, implementation is the next step in the performance improvement cycle. C, all necessary data have already been compiled. D, the process has not been completed, so there's nothing to share at this point. So what's your answer here?
Implement change.
Yes, implementation. Very good. So after all compiling all necessary data, the next step is, okay, in the performance improvement is to implement the identified changes. So this one is to address all the unresolved issues. Okay, next would be this for the compiling data or sharing results prematurely or secondary to taking action on the improvement plan. Clear, Radha? Okay. Next, number 7, the evaluation of the quality and appropriateness of patient care in the radiology department is the responsibility of the, okay, who? A, medical director of radiology. B, chief medical officer. C, medical director of the quality department. D, administrator of clinical services.
Radiology, medical director of
Yes, it's the medical director of radiology. So, medical director of a department has the chief responsibility for everything within the department. So, for letter B, the chief medical officer is responsible for the facility-wide medical staff operations, while for the director of the quality department is only for activities within the quality department. While letter D, the administrator of clinical services is responsible for the facility-wide clinical activities, while the medical director of radiology has what is this? Chief responsibility, direct responsibility, responsible for overseeing the quality and the appropriateness of patient care within the radiology department. Very good, Radha. Okay, number 8. All of the following can be utilized as measures of utilization performance except A, number of encounters in outpatient clinic, B, ALOS in acute inpatient care or the average length of stay, C, denials of service, D, LIP's appraisal. Except. So what's the answer
denials of service.
Okay. No. The answer here is letter D, LIP's appraisal. Because this refers
to... What is
LIP? The LIP stands for license.
Practitioners?
LIP stands for, wait, hold on. License.
Practitioners. Licensed practitioners.
Yes. Yes, this is the correct answer. Okay, because this one refers to evaluating the performance of individual healthcare providers, which is related to credentialing and competency assessment. So this is not directly to utilization performance. Okay, so for the number of encounters in outpatient clinic, this one is the measures the volume of services provided, reflecting the utilization rates. For the ALOS, or the average length of stay, is a common utilization metric used to assess resources, efficiency, and care delivery. Why not denials of service? As you
Again,
have
it
answered.
included in the measures of utilization.
Okay. Okay. What's your answer? About the denials? This one
I
is
said this is again measures the utilization performance.
Okay. So this one, denials by insurance companies or other payers, or an indicator of utilization programs. So this reflects issues with the authorization or the appropriateness of services. So the correct answer here is the LIP's appraisal, or the licensed independent practitioners. Okay. So clear na, huh? So this is not a utilization performance. So number 9 is which of the following is not included in the organization plan? Letter A, evacuation plan. B, mission and vision statements. C, explanation of the governing board's responsibilities. D, scope and purpose. What's your answer?
C.
Letter C,
C.
which of the following not included? Careful to read the question carefully. Okay, because the keyword here is not included. So what's your answer? It would be
organization plan, evacuation plan.
Yes, very good, Radha. Yes, the answer is evacuation plan. That's the answer. Okay. When we say organizational plan, this typically includes elements like the mission vision statement, the scope and purpose, and the governing board's responsibilities. So when we say this mission vision statement, this is incorrect. These are essential component of the organizational plan. For the letter C, explanation of the governing board's responsibilities is incorrect. Okay. So because the organizational plan typically outlines the roles and responsibilities of the governing board, as this is crucial for defining the leadership and decision-making process. Why not letter D, the scope and purpose? Because as they define the boundaries and objectives of the organization's operations and its reasons for existence. So this is incorrect. Okay. So the answer is evacuation, which is not included in the organization plan. Okay. Number 10, which of the following process is most cost-effective in preventing unnecessary resource consumption in the hospital? So letter A, effective pre-admission screening. B, accurate DRG assignment at admission. Second, opinion for all surgeries, letter C. And pre-admission insurance benefit denials for letter D. Okay, what's your answer? What's your answer here?
Effective pre-admission.
Effective pre-admission
DRG, what is DRG?
DRG means the diagnosis-related group. It's a classification system used in healthcare to categorize patients into groups basing on their diagnosis, treatments, and other relevant factors. So the answer here is what letter?
B.
A, effective pre-admission screening. Yes. Okay. As you can see here, this is the most most cost-effective way
effective in
to
preventing
prevent unnecessary resource consumption in hospital. So by assessing the appropriateness of admission and plan procedures beforehand, so hospital can avoid unnecessary hospitalizations, thus reducing any complications and
cost.
optimizing the resource use.
Yeah.
Okay, as you can see here, the effective pre-admission screening is the proper assessment of the patient. For letter B, this is wrong because to check the diagnosis related group is to know the cause of the treatment, okay, which is part of the admission. So for this letter C, second opinions for all surgeries, this is to consider practice versus the guidelines. While letter D, this is incorrect because this is not related to the what is this? The preventing the unnecessary resource consumption. Okay. Clear, Radha?
Yes, yes.
Okay, number 11, utilization management assessments measures A, how practitioners utilize performance improvement data, B, the use of services, procedures, and facility resources, C, how employees utilize outcomes and manage daily responsibilities, and D, the use of high-risk equipment and the level of risk.
B,
Okay, when we say
the
utilization,
use of
meaning
services,
resources.
procedures, and facility resources.
Yes. Okay. So what's your answer, letter?
B,
Letter B?
B.
Okay, very good. The use of services. So meaning utilization management assessments focus on evaluating how effectively and efficiently healthcare services, procedures, and facilities are being used. Okay, so for letter D, the use of high-risk equipment and the level of risk, this is a risk management. For letter A, this is incorrect because this relates to quality improvement efforts, not utilization management. For letter C, this is also incorrect because this pertains to workforce management. What for letter D, this is about the risk management. Okay, so we are clear for about this one. Number 12, which of the following is not relevant to include in both utilization management and quality management plans? What's your answer? A, confidentiality policy. B, process for appealing treatment denial. C, conflict of interest policy. The provision for annual program evaluation. What's your answer, Radha? Okay.
Both
What's your answer?
utilization and management plans.
Okay. The correct answer here is letter B. So here the keyword here is appealing.
B.
So this is applies to utilization management. Okay. So why letter A is not relevant? Okay.
It is quality plan.
Okay. The question is, which of the following is not relevant to include in both? So meaning the A, confidentiality policy, conflict of interest policy, and provision are all relevant for the utilization management. Okay. So they are all included in or they are all relevant in utilization management and quality management plans. So letter B is the answer here, which is not relevant, which is the process for appealing treatment. Okay, denials. So which prioritizes the patient outcomes and service quality rather than administrative process. Okay, number 13. The primary purpose of an emergency preparedness program is to A, conduct evaluations of emergency training, B, provide evaluations of semi-annual evacuation drills, C, prevent internal disasters that disrupt the facility's ability to provide care and treatment, D, manage the consequences of disasters that disrupt the facility's ability to provide care. What's your answer here? Okay, letter?
D.
Okay, it's letter D. Okay, the answer here is letter D, manage the consequence of disasters that disrupt the facility ability to provide care. This is the primary goal of an emergency preparedness program, ensuring an effective disaster response. So for the other options like training, evaluations, or preventions are only secondary aspects. Okay. Number 14. The healthcare risk manager is usually responsible for claims administration. So which of the following is included in this process? A, investigating, analyzing, and reporting. B, quality management, patient satisfaction surveys, and resource management. C, contracting, reporting, and resource management. D, patient satisfaction surveys, contracting, and investigation. What's your answer, Radha?
Yeah.
Very good. Okay. Because these are core. These three are the core task. Okay, core task of in claims
manager.
administration. So ensuring incidents are properly managed. Well, for the other three, these are all unrelated tasks, like the patient satisfaction service or the resource management. Okay, number 15. Which of the following is not true regarding incident reporting? Okay, which is not true regarding incident reporting. So meaning the false statement and the other three are correct. A, it is a practical method of risk identification. What do you think? Is it true or false? It is.
It's true.
Yes, and incident reporting is a practical method of risk identification. Very good. What about letter B? It minimizes risk by reporting the incident close to the time of occurrence. Is it true or false?
True.
True. Very good. What about letter C? It is the responsibility of any facility staff member who is part or has knowledge of the incident to report. Is it true or false?
True.
Yes, very good, because all staff members are responsible for reporting incidents. What about letter D? Reporting policy should be department specific. Is this true or
No.
false?
False.
False. So this is the answer. Letter D, because this is not true regarding incident report. Okay, very good, Radha. Because incident reporting is an organizational wide, not is the department specific. Okay, number 16, an integral part in the process of determining medical necessity in the delivery of quality medical care, including weighing the potential for undesirable outcomes and side effects against the potential for positive outcomes of a treatment, best describes letter A, cost-effective medical care. B, efficacious medical care. C, efficient medical care. D, risk-benefit analysis. Which one is true? Which one is correct? Positive outcomes of a treatment. Keywords, positive outcomes of a treatment best describes.
Yes.
What's your answer? Letter?
Yes, medical care. B or C, I don't know.
Okay, the correct answer here is cost-effective medical care. Yes, because it balances quality outcomes with financial efficiency. When you see this cost-effective all at all, this is about financial, okay? So this addressing medical necessity within the broader framework. Okay, so this ensures also that the chosen treatment provides the best possible outcome for the patient. So while also considering the financial efficiency of the resources used. Okay, so that's the rationale. Why not letter B? This is incorrect because efficacious care evaluates the effectiveness of a treatment under ideal conditions, not the cost effectiveness or necessity in practice. Why not letter C? Because this pertains to achieving outcomes with minimal waste, but not directly addressing the balancing quality with cost. Well, letter D is incorrect also because this is a component of determining medical necessity. The cost effectiveness encompasses this within a broader framework of financial and clinical appropriateness. So again, cost-effective medical care is something about the framework of financial and clinical appropriateness. Clear, Radha? Okay, number 17. Which of the following is the primary goal of risk management? Primary goal of risk management. Letter A, identify the high-risk areas of the organization. B, maintain an effective incident reporting system. C, perform failure mode and effects analysis or FIMIA. D, reduce financial loss associated with legal actions. What's your answer?
Yeah.
Letter primary goal of risk management. Reduce financial loss associated with illegal actions. This is the correct answer. So as you can see here in the slide, so how you will identify the high risk areas of the organization is doing the risk management. We have the risk identification. We have to do the risk assessment. We have to do also the risk handling, and to have a to check the communication and evaluation. So the primary goal of the risk management is to what? Increase patient safety as always and reduce financial loss. Yes, primary goal always reduce financial loss associated with legal actions or increase patient safety. Yes. So clear, okay? Number 18, a utilization management department of a hospital has collected data on length of stay and readmission rates compared to benchmarks. The length of stay rates are higher and readmissions rate are lower. So which of the following is the next step? Okay, this is to identify the address and address the causes, okay? So this is about the identification and addressing the causes, what the statement is asking about. So we have choices here. Letter A, identify the additional benchmarks to compare the data. B, conduct a cost-benefit analysis. C, display readmission rates with a run chart. D, investigate the length of stay rates. What's your answer?
Conduct a cost-benefit analysis.
Okay. A utilization management department of hospital has collected data, already collected the length of stay and the readmission rates. So it was compared to benchmarks. So the length of stay rates are higher and readmission rates are lower. So which of the following is the next step? So in here, the statement is for you to identify and to address the causes. So what you will do? What you think you will do? What's your answer? To?
Benchmark again?
To investigate
the length of
You
stay.
do investigation. Since the length of stay rates is what? High. Right? Then benchmarks.
So investigate the length of stay.
Yes, the next logical step here is to investigate the reasons behind the prolonged stay. For you, this can help to identify inefficiencies, any barriers to discharge, or unnecessary delays that need to be addressed. Okay, what was your answer? Letter A, this is incorrect because the existing benchmarks already indicate that the length of stay is an issue because the length of stay rates are higher. So further comparisons are necessary at this stage. Clear? For letter B, this is incorrect because this does not directly address the issue of the higher length of stay rates. So for letter C, this is incorrect also because readmission rates are already lower. Okay, so further analysis of the data is about the length, why there is a length of stay rates. Okay, clear? Okay, number 19. Case management is a comprehensive process that involves Okay, letter A, individual assessment. B, assessment of cohorts of similar patient groups, assessment of each DRG. D, assessment of the entire community. What's your answer? Yes, Radha.
Assessment of
What's your answer?
cohorts.
When we say cohorts, it is a group of individuals who share a common characteristics or experience with a defined time period. So this cohort is also used to describe a group of people studied over time to analyze outcomes or behaviors related to specific factors. So this is not the answer. Okay, this is not the answer. Again, the question is case management focuses on what? On
Process.
on individual assessment. Okay, individual assessment. Because when we say assessment of cohorts of similar patients, this is related to disease management. And while for the letter D, assessment of the entire community, this is about a demand management. For individual assessment, case management is a personalized process that involves individual assessment to coordinate and optimize care for specific patients. It also focuses on evaluating each patient's needs, developing a tailored care plan, and ensuring efficient resource utilization. Your answer was assessment of cohorts is incorrect because this approach is more aligned with population health management. And as I said, it is a disease management. Assessment of each DRG. Okay, when we say DRG, what was the meaning? What is the meaning of DRG? It is a diagnosis related group. This is incorrect because diagnosis related group assessments, this pertain to resource allocation and billing. So not a comprehensive care of individual patients. Letter D, assessment of the entire community. This is incorrect because this is pertains to demand management. Okay, clear? Clear, okay? Case management is comprehensive process that involves individual assessment. Okay. Number 20, pre-authorization is required for all of the following, except, meaning there is one that is not correct answer, except. So what's the answer here? Letter A, inpatient acute care. B, ambulatory care. C, rehabilitation. D, psychiatric care. What's,
Rehabilitation.
no, this is not rehabilitation. Pre-authorization. When we say pre-authorization, what's your answer?
Yes.
When we say pre-authorization, Radha, this is also known as prior because pre means before. So prior authorization, this is a process required by insurance providers to approve specific medical treatments or procedures before they are provided. Okay, so which one here is not requiring a pre-authorization? Okay, when we say it is
inpatient acute care.
No, the answer is ambulatory care, which is the outpatient care department. Okay. Because they don't, this refers to outpatient services and they don't need pre-authorization because these are our routine doctor's visit, minor procedures, diagnostic tests, or preventive care like vaccinations or checkups. Okay. The inpatient acute care, this requires pre-authorization. What do you think is the reason? What do you think is the reason, Radha? Because these ensure medical necessity and proper use of resources. And, hospital admissions are expensive, and this involves significant resource use. For example, any surgeries or intensive care. And these insurers or the companies require the pre-authorization to confirm the necessity of hospitalization and ensure that less costly alternatives have been considered. Okay. While letter C, rehabilitation, this also requires pre-authorization. Why? Because to confirm the necessity and expected outcomes of the therapy. So services like physical therapy, the post-acute care. Okay, so this one, the resources is intensive and long-term. That is why it needs authorization. What about psychiatric? This is also pre-authorized because this helps the insurers confirm the diagnosis and the appropriateness of the treatment plan, avoiding unnecessary costs or services. So is it clear? That is the meaning of the pre-authorization. So all are except ambulatory care or our outpatient care department. Okay, to err is human. Crossing the quality chasm, who wrote this report? A, IHI, B, IOM, C, AHRQ. What's your answer?
IOM.
Very good. Yes, this is the correct answer. Okay. Any questions so far? Number 21, when analyzing complaints, the CPHQ would not A, report to the governing board the details of all complaints, B, establish a time frame for complaint resolution, C, review pertinent bylaws and regulations, D, categorize complaints by type, department, or area of concern. What's your answer? Okay, what's your answer? Letter? When we say governing body only receive summary, so not details. Okay, so this is the correct answer. Letter A. Okay, yes, because the CPHQ, okay, or the Certified Professional in Healthcare Quality, focuses on analyzing and managing complaints effectively, but does not report individual complaints, all the complaints details to the governing board. So they don't report all the details. So instead, they typically provide the summary data, the trends, or aggregated analysis, to avoid overwhelming the board with individual case details and to focus on actionable insights. So that's the reason. Well, letter B, this is correct because timely resolution is critical, okay, in complaint management, and it is part of the CPHQ responsibilities. For letter C, this is also correct. Okay, because this ensures the complaints are handled in compliance with the organizational and legal requirements. For letter D, this is also correct. Categorizing the complaints helps identify the trends and areas for improvement. So letter A is the correct answer. The CPHQ would not report to the governing board the details of all complaints. Okay, so last is the deemed status means A, accreditation equivalency of meeting conditions of participation in Medicare and Medicaid programs. The Centers for Medicare and Medicaid Services, or the CMS, accredited organization. What's the answer? Deemed status means deemed. Deemed status means? Yes. Yalla Radha. What's your answer? It's letter. Hello, Radha? Okay. The correct answer here is accreditation equivalency of meeting conditions of participation, Medicare and Medicaid programs. Okay, this deemed status means that the healthcare organization has been accredited by an approved accrediting body like the JCI. Okay, so it is recognized as meeting the conditions of the participation or the COPs set by the Medicare and Medicaid programs by eliminating the need for direct evaluation by the CMS as the accreditation is considered equivalent. So letter A is the correct answer. Okay, so that ends the quiz, final quiz number 2. Okay, any more question? So that ends now. So if none so far, so I'd like to end this lecture. Thank you for listening and thank you for your patience. So tomorrow will be about data analytics part 3 and final quiz number 3. So good evening, everyone, and wassalamu alaikum. She left.